All right. Usually in school, it's a little bit more exciting than it is now. But today's the last lesson, 12.7. So the last formal lesson that we'll have. I forgot to delete the date, so don't worry about the date. Obviously, it's not May 14th when you're watching this. 12.7. We've done the fundamentals of 12.7. It just takes the fundamentals one step further. In chapter 11, we dealt with the idea of how you can use the ratio of your sides to talk about areas. And we said if the ratio of sides was 3 to 5, the ratio of those areas would be that ratio squared. So it would have been 9 to 25. Well, in chapter 12, since we're dealing with three-dimensional figures, when we go to deal with volume, we can likewise use that ratio to get there. If you square it to get your ratio of areas, we are going to cube it to get your ratio of volume. 3 cubed is 27. 5 cubed is 125. Right? So that would be our ratio of volumes of those similar figures. So take a look. The idea is similar solids. Two solids would have to be the same type with equal ratios of their corresponding linear measures. That refers to, in the case of a cylinder, your radius and your height. You're looking at edge lengths for pyramid or for prisms. You're looking for edge lengths and slant heights and regular heights for pyramids and cones. Right? So there's all types of different things that you can look at, but it's any linear measure that you're going to be looking at. So in example 1, it says, tell whether the given right rectangular prism is similar to the right rectangular prism shown below. So here we're just going to start. We compare. I'm looking at those ratios, 4 to 8, 2 to 4, and 2 to 2. I got 1/2, I got 1/2, I got 1. So A does not work. Looking at B, my ratios, I got 4 to 6, I got 2 to 3, I got 2 to 3. So 4 to 6 is 2/3, 2/3, 2/3. So here, B is similar to my original one. Right? And that's how we know. So taking a look at that independent practice then, same idea. Just look at those ratios of your sides, or your edges, I should say. So we got 12 to 9, 16 to 12, 4 to 3. 12 to 9 reduces to 4 to 3. 16 to 12 reduces to 4 to 3. And then 4 to 3 was already 4 to 3. So here it is, yes. Looking at my height and my radius here of my cone. I got 15 to 5, or I'm sorry, 15 to 10 for my heights. My radius is 10 to 5. 15 to 10 reduces to 3 to 2. 10 to 5 reduces to 2 to 1. So here it is in those. And that's how we tell. So, as we talked about in the opener, if two similar solids have a scale factor of A to B, their corresponding ratio or their corresponding areas have a ratio of A squared to B squared. Their corresponding volumes have a ratio of A cubed to B cubed. Take a look at example 2 then. It says the cans below are similar with a scale factor of 87 to 100. Now, unfortunately, that does not reduce. So, when I go to find the ratio of my surface areas, I have to take that 87 and square it. I get 7,569. 2, I take my 100 and I square it. And I get 10,000. For the ratio of volume, I take my 87 and I cube it. I get 685,503. I take my 100 and I cube it. Whoop, sorry, I put my comma in the wrong place. And I get 1 million. So there are my ratios that we're going to start with. Then it says to go through and find the surface area and the volume of the larger can. That means that these surface area and volume here, this goes to my smaller can. So for surface area, we use the ratio of surface areas. So 7,569 over 10,000 equals surface area of my small can is 51.84 over the surface area of my larger can is my x. So now we just cross multiply and solve. 51.84 times 10,000. And then I'm going to divide that by 7,569. We get your surface area of the larger can to be 68.49 inches, and in this case, since it's surface area, squared. For volume then, we use our ratio of volumes. 685,503 over 1 million equals, in this case, the volume of my smaller can is 28.27 over x. Cross multiply again. Take your 1 million times your 28.27, and then we're going to take that and divide it by our 685,503. We get a volume of my larger can to be 41.24. And in this case, we're dealing with inches cubed, since we were looking at volume. In example 3, it says your pyramids are similar. Pyramid P has a volume of 1,000 cubic inches. Pyramid Q has a volume of 216 cubic inches. It says find your scale factor of Pyramid P to Pyramid Q. Well, if you needed to go through and find got my words mixed up there. If they tell me here now I have volume being 1,000 and volume being 216. To take your scale factor, we had to cube it to get volume. So to use our volume to go backwards, I will have to cube root each of those. So since your volume's here, and they want it in Pyramid P to Pyramid Q, so if your volume is 1,000 to 216, to get back to your scale factor, I need to cube root that. Taking the cube root of 1,000, you get 10. Taking the cube root of 216, you get 6. So right now we have a ratio that says 10 to 6, but just like all ratios, we do have to reduce it. Reducing it, we get a ratio of 5 to 3. So that is our scale factor of Pyramid P to Pyramid Q. Alright, last example here. Example 4. It says a store sells balls of yarn in 2 different sizes. The diameter of the larger ball is twice the diameter of the smaller ball. So first thing we know right away is our scale factor. Scale factor, the larger ball is twice the diameter of the smaller ball. So my scale factor is 2 to 1. It says if the balls of yarn cost $7.50 and $4.50 respectively, well, yarn is rolled up into a ball. So it is volume that is your $7.50 to $1.50. Now, I cannot directly relate ratios of a scale factor to ratio of a volume. I need to take my ratio and I need to make it a ratio of volume. 2 cubed is 8. 1 cubed is, well, that's still 1. So the ratio of my volumes is 8 to 1. The price is $7.50 to $1.50. When we look at this, what this actually tells us then is I can buy 8 units for $7.50. Or I can buy 1 unit for $1.50. It wants to know which ball of yarn is the better buy. So if I did 8 units for $7.50, that means I am paying $1.07 per unit. Here I am paying $1.50 per unit. Well, which one is the better buy then? The $1.07, the larger ball. Alright, that finishes up Chapter 12. As we said at the beginning of the year, we were going to try to get through all 12 chapters. That was the goal. Definitely did it a little bit of a different way this time. Homework is pages 850 to 851, numbers 3 to 19, the odds. As far as a Chapter 12 test goes, I am actually going to cancel it. There is no chapter test. Right? Today's assignment is the last assignment that you are going to have. Check in tomorrow. I'll have something little there posted, but today is your last actual official assignment. So if you have questions, concerns, anything, please email me, and we'll take care of it. All right, everyone. Talk to you tomorrow.